Bonjour, baddies. Welcome back to my videos. Problem number 11 of the 2023 AMC8. NASA's Perseverance rover was launched on July 30th, 2020. After traveling a very large amount of miles, it landed on Mars in Jezero Crater about 6.5 months later. Which of the following is closest to the rover's average interplanetary speed in miles per hour? So, firstly, for this problem, this is obviously a very obvious estimation problem because there's no way the AMC8 would send you to bat with this divided by this, multiplied by some number after you calculate how many days were in each month, and then we multiply by 24 and we divide, blah, 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 blah. Obviously you can do that, but that would be extremely time consuming. So first we're going to round this big number. And when we round the number, we can basically round it to a 3 with 8 zeros because it's pretty close because it's basically a 2.9. So we basically have 3, 0, 0, 0, 0, 0, 0, 0, 0. Funny. And under it, since it's 6.5 months, and we don't actually know we do know what months it covered. However, there's really no time to calculate. 30, 31. Was it a leap year? Who knows? But we don't really have much time to calculate that, so let's just estimate that each month has 30 days. So we basically have 6.5 multiplied by 30, and each day has 24 hours multiplied by 24. So obviously you can simplify top and bottom first, so we get rid of this 30, get rid of this top one 30 as well, getting you this number. And which of the following is closest to the rover's average interplanetary speed in miles per hour, we still need to solve. So we basically have here 24 multiplied by, 24 multiplied by 6.5. So this is 20, 5 multiplied by 2, that's 10, 12, 24, 12 as well, that's 14. So adding it up, adding the decimal point, just get rid of that 0 at the end, 156. And since this is already a pretty vague rounding problem, and as you guys can see specifically in this problem, the answer choices have a pretty large distance apart. So you can do this, but if it was really crammed together, like if one answer choice was 12,000 and the other was 13,000, you probably wouldn't be able to round so vaguely, but you can in this problem, as long as you know the amount of zeros and what the first number is. So we can basically round 156 to about 200 or so. So if we round it to about 200 and divide that from this number, we can get rid of these two zeros and you basically get a number approximate to 50K. And the only number that's actually somewhat close to that is C, 60,000, because it's obviously 600,000, way too out of reach. 120,000, also out of reach. 12,000, too small. 6,000, also too small, doesn't even have the same number of zeros. Therefore, the answer is C, 60K. So yeah, that's the end of this video. I hope you guys enjoyed it, and I'll see you all on the next one. Bye-bye!